In today's lesson, we want to use to find the limits as x approaches infinity and use the ideas to find horizontal asymptotes. So at the end of the lesson, you should answer the question. Our essential question is, how do we find horizontal asymptotes? You will see many different ways that we can use to find horizontal asymptotes. So, what is the limit as x approaches infinity of any function? What does it mean, the limit as x approaches infinity? First, what's the meaning of the word infinity? Infinity simply means a very large number. So to find the limit as x approaches infinity, we are simply going to find the limit as x becomes very, very large. The value of the function as x is very large. And if it is negative infinity, it is when x is very large in the negative direction. Right? Okay, example. We want to find the limit as x approaches infinity of 1 over x, and the limit as x approaches negative infinity of 1 over x. Let's first take infinity, so we can use our numerical approach, 1 over x. So as x is getting close to infinity, this means x is becoming very, very large. Let's say x is 100, 1 over x is 0.01. When it's say 1000, 0.001, and when it's getting very, very large, as we can see here, let's say 100,000, 0.0001. Yes, so the limit should be, we see that this value is getting close to 0 from the right side. Right, so this limit should be 0. The limit as x approaches negative infinity, we would use the same method. We use the numerical approach, x 1 over x as x is approaching negative infinity. Actually, there is no difference between you can, it means that x is getting very large from the negative direction. Say negative 100, you get negative 0.01, negative 1000, negative 0.001, say negative 10,000. So we see that it is also getting close to 0 from the negative side, right? Because negative 0.0001 is close to 0 from the negative side. So it's getting close to 0 from the negative side. So this is also 0. Example 2. Now, as I told you before, there will be many different methods that we can use to find limits as x approaches infinity. But we start with the idea that the limit as x approaches infinity of 1 over x is always 0. 1 over x squared will also be 0. So, how about limit as x approaches infinity of sine x over x? Okay, now we have to use one of the rules that we learned before, the squeeze theorem. We remember that sine x lies between 1 and negative 1, the squeeze theorem. Now we can multiply this by 1 over x. So you get negative 1 over x will less than or equal to 1 over x times sine x less than or equal to 1 over x. Now we know that the limit as x approaches infinity of negative 1 over x is 0, and this is the same as the limit as x approaches infinity of 1 over x. This means that the limit as x approaches infinity of sine x over x, the middle function, should also be 0. Right? Okay, now, how about the limit as x approaches infinity of a 5x plus sine x all over x? For this function, this is the same as the limit as x approaches infinity of 5x over x plus sine x over x, right? Which is the same as the limit as x approaches infinity. We know that the x will cancel out here. So it's the limit as x approaches infinity of 5 plus the limit as x approaches infinity of sine x over x. And we know that this limit is 0. We have just shown that it's 0. And this other limit is 5. The limit of a constant is the constant. So this whole limit will be 5. Special functions. As you will see in the videos that will follow after this video, rational functions are very special functions for finding limit as x approaches infinity. If you have the function f of x is some function q of x over p sub x, this is a rational function, and there's a special way for finding the limit. We will still use the idea that the limit as x approaches infinity of 1 over x is always 0. That idea will be very useful in rational functions. You will see lots of examples of rational functions in the video that follows. And if you still cannot find the limit as x approaches infinity, draw the graph and you will see how the graph looks like. For instance, if I have a graph that looks something like this, so I have the graph of 2 raised to the power x. For example, the limit as x approaches negative infinity of 2 raised to the power x is just from your graph. You are just going to look at negative infinity. This is this way. So 2 raised to the power x is getting close to what? To 0, right? So it is 0. It gets close to 0. Horizontal asymptotes. If you can find the limit as x approaches infinity of any function, then you just take y equal that limit. It will be the horizontal asymptote of that function. It will be the horizontal asymptote of that function. And the limit as x approaches infinity equal L, or the limit as x approaches negative infinity equal L, both infinity or negative infinity. If it's equal to some value, then y equal that value is the horizontal asymptote. So if we go back to our examples here, so the line y equals 0 is the horizontal asymptote of 2 raised to the power x. We know that already. If we go back here, the line y equals 5 is the horizontal asymptote of this function here. And the line y equals 0 is the horizontal asymptote of sine x over x. And the line y equals 0 is the horizontal asymptote. Y equals 0 is the horizontal asymptote of 1 over x. So that is how you find horizontal asymptotes. Watch the rest of the videos below to see more practice on how to find limits as x approaches infinity. Thank you.